All right, in order to see if we have good results for our calibration, we'll quickly want to switch it over to the Smith chart. And the way to do this, let me clarify, is you go over here, you click Format, and it'll initially be in LogMag, but you just change it into Smith chart. Okay. So, in case you've never seen a Smith chart, just a real quick overview. In the center, we have a 50 ohm load. On the left, we have a short circuit, and on the very far right over here, we have an open circuit. Now, what we want to do is look at our system, and we see that there's a 50 ohm load connected. So that means all of our data points should be showing up right here in the center. And we can see that indeed they are. So this is a decent calibration already. Now if I disconnect the 50 ohm load, now it's an open circuit. There's nothing connected to the end. And you can see all my points went over here to the open. So now I still have a decent calibration. Now finally, if I connect the short calibrating standard to the end of my system, I should see all the points go to the left. And once I tighten it down, we can see that indeed they're all on the left. They're all over here. So we know that this is a pretty good calibration. Now, something I'm going to point out in this video, I'm going to quickly reconnect the 50 ohm standard, and we can see that all my points are decently centered in the center. Now what I want to show you is the value of using tape and other stuff while calibrating to get more accurate results. It's not going to be very important in this course, but it's definitely relevant to this conversation. This is how the system looked while I calibrated. If I take my cable and I wiggle it around, maybe I even take this and I fold it over here, or something like that. I don't know. Basically what I'm trying to do is introduce phase error. The reason why I'm doing this, it's probably hard to see in the video, but you can see that the points in the center of the Smith chart are changing size and location. The reason why that's relevant is because the more rigid this system is when you calibrate it, the more accurate your data is. And as small changes are introduced in the system, your calibration will be less accurate, making your data less accurate. Thanks for watching.